Mike Parsons, welcome to Software Engineering Daily.
Alex, thanks for having me on.
Absolutely. So you're the CTO and co-founder of Twisp. We had your other co-founder, Jared, was on Software Engineering Daily recently. But for those that don't know, could you tell us more about what Twisp is, what you're doing at Twisp?
Yeah, so Twisp is a ledger accounting system in the cloud, API based. The whole idea was to have a set of primitives that felt like an AWS service for accounting and ledgering. And we were surprised that AWS itself doesn't offer exactly that. You see things like Elastic, where it's full text search as a service, or some of the ML offerings where they can do text classification as a service. And so it was interesting to us as co-founders who have a background in financial services that these higher level primitives weren't available, and so we set out to make them. And the story of that is long, and I think we can get into it a little bit here today.
Yeah, for sure. I want to hear about your background and how you went down this road. But first, let's just talk about ledgers because I think over the last couple of years, whenever I hear the word ledger, I hear distributed ledger, automatically goes to crypto and things like that. But that's not quite what Twisp is. So, maybe for even those that don't have an accounting background, like what is a ledgering system and what does that mean outside of the crypto context?
Yeah, so I mean, from a fundamental usage of the word ledger, what we take that to mean is an append-only data structure. Um, and so we use that lower level primitive to build higher order primitives like accounting systems. And when you're dealing with accounting systems, you're dealing with like the usual things: transactions, journal entries, a chart of accounts of some sort, and a way to compute balances across different dimensions of accounts and time periods. So for us, that's what we mean by a ledger accounting system, is something more closely that you'd find in a core banking system or in a payments system where you're trying to keep track of balances for different accounts.
Yeah, I remember taking accounting classes in high school, which I thought were super interesting. But yeah, that ledger notion, very powerful. I guess how did you get into this? Do you have an accounting background? Like, what led you to want to build this ledger primitive?
I do not have an accounting background. I started my software engineering journey on a different kind of rails, writing train software for positive train controls. And this is early 2000s, writing C code. The second .com boom was getting underway, and I uh, was fortunate to land a job in that sector at a company called Seamless Web. They were doing online food ordering, so for law firms in New York City. And so I thought it was kind of cool that you could uh, place an order in a menu, and it would get faxed to a restaurant, and somebody would pick up a piece of paper and say, "Oh yes, this is Mike wants some Thai food. We're going to make that for him, and he can come pick it up, or we'll drop it off to him." And so building those systems is obviously the first exposure I had to like a multi-sided market and payment integrations. We were using Chase Payment Tech at the time in a very low level way. There wasn't cool tools like Stripe or Braintree out there to do payment processing. So that's where I really had my first encounter with the financial system, was doing invoicing, processing payments, making sure orders settled, things of that nature. Uh, Later on, I moved to Portland, Oregon, and I kept hearing about a company called Simple, where they were making a bank that didn't suck. And this was right after the financial crisis, and that message really resonated with me. And so I put an application in and was fortunate enough to get hired there. And that's where the real learning began, where now you're interacting on the issuing side of card issuing. You're building accounting systems, keeping track of all different types of payment instruments, and really just learning the hard lessons of running a bank from essentially first principles again. One of the interesting things about banking is they were the first industry to really adopt computing, and once they solved all their problems, they stopped. And so you have to go and relearn all these lessons to make banking not suck. And so that's what we did at Simple for many years.
Yeah.
Uh,
And I'm sure you just have a ton of deep domain expertise on this, both from Seamless and Simple. Like, who needs this sort of ledger technology? Is it mostly banks like Simple, or like multi-sided marketplaces? Like, who needs a ledger?
any company that is dealing with money inside of their product is who we have a strong opinion needs a ledger. So a marketplace would, obviously neobanks would, folks who are doing embedded finance where maybe they have a lending program inside their e-commerce platform, they'll want to have ledgers. They're actually fairly pernicious throughout the industry as well, like insurance. When you create an insurance claim, that's a line in a ledger. Uh, the payout is also a line in a ledger. So it's this ubiquitous thing that has a lot of a lot of different uses across different industries. And oftentimes, when you're innovating product, you're not going to bring in the SAP system and hook that up to your React app, right? And so
Yeah.
that's been a huge challenge. Is like, how do you build these systems that have strong guarantees about the numbers without spending $12 million to get the licensing and use a worse product at the end of the day.
Yeah. Yeah. And one thing you were telling, I think we were talking, and you said even like games, right? Games that have in-game economies, they need this sort of thing. So not even real money in a sense, but money that's representing something in a game needs this sort of thing as well.
Yeah, that's a super interesting thing. Is a lot of in-game economies also interact with the real world as well. So you can earn things by accomplishing things in a game, and they'll give you some sort of token that represents a currency you can use to upgrade your character or buy things with. Or you could do the Mike method where you just get out the credit card and say, "I suck at this game. get, get me the
Give
upgraded
me more
armor."
jewels, right? Yeah, give me everything I
Right.
need. Yeah.
Right. Um, so, but uh, it's very important to get numbers right, even in that context, because when you get the numbers wrong, it violates a trust, right? And it's kind of silly humans, even in a video game, where if they took away your token and you don't have a clear reason why you don't have that token anymore, you get mad. You get mad at the game. You and so having good numbers that are kind of the foundation of building trust. Like, you have to have that. It's table stakes, but oftentimes, like, table stakes things are extremely difficult to deliver on.
Yeah.
uh, and I think that's where you start to, at least that's how we view the world, is um, when you need a world class result just to get to the table stakes. uh, Maybe it's a good time to find someone who's really good at that, and have them do that work while you layer on top the things that you do well.
Yeah.
And I think
Absolutely.
that's been a theme of learning about how to build systems and software over the years that we've encountered.
Absolutely. And I want to talk about the special challenges of sort of payments and accounting and all that stuff. One last thing, just to like, I still feel like I'm orienting myself on terms of where Twisp fits in, and in terms of fintech or payments, I think of Stripe, as like the big gorilla in the room. Like, where does Twisp fit in relation to Stripe? If I'm a company, am I using sort of both Stripe and Twisp in some ways, or is Twisp replacing part of Stripe, or like does Twisp actually issue the payments? Where does Twisp fit in relation to something like Stripe?
Yeah, so at the risk of finding a horse head in my bed, we view ourselves as a complement to Stripe. Now, Stripe is, as you said, is a behemoth. They have
Yeah.
a treasury product. They have a Connect, which is a multi-sided market product. They have acquiring products for just regular payments. All kinds of different things you can do on Stripe. Uh, you can adopt the Stripe ecosystem wholesale and center your whole business around Stripe and grow and become massively successful and rely on their accounting. Um, the the key here is like when you have the capability to venture out on your own. Let's say you're using Stripe Connect, everything's going good, but you don't like the way payouts work in Stripe. So you might spin up a partnership with a banking partner and start sending ACHs so you have full control over how payouts work. You might decide, hey, we want to do payouts. We have a banking partner. We're going to actually do accelerated payouts where we're going to have a line of credit and we're going to issue a payout that way. As soon as you add that second party, that's when you need to be in control of your destiny on the accounting side. You need to know what the balance of the customer's account is. You need to know what the balance on the line of credit is. And so introducing an accounting system in that context makes a ton of sense. Another use case might be uh, just picking on Stripe a little bit for a moment is, wow, this other company has way cheaper rates for cards. We need the ability to maybe load balance or in the case of an outage, switch over to another provider. And in that case, you also want to have a system of record that has the ability to keep track of transactions and balances so that you can have a little bit more control over your own destiny.
Yeah, absolutely. I hope you survive any issues with the mafia there. But
Thank
in
you.
terms of let's talk about the domain, because I find like, whenever you talk to people that are really in their domain and have this system, there are all these just like hidden complexities under the surface that you just don't even appreciate or realize, especially when you try and build your own as opposed to buying something. So what makes this area particularly complex, or what will people underestimate as they're sort of maybe thinking about doing this themselves as opposed to using Twisp?
Yeah, so uh, it's really fun to build an accounting system from first principles, right? Because you you have a lot of success because you can have almost like a spec. I need accounts, I need transactions, I need journal entries, and I can implement this. I don't want to call it a toy model, but I can implement a model of my system. And what happens a lot of times in organizations is there's an impetus for doing that activity. Hey, we're going to go offer a service, or we're going to charge some customers money to use a thing. And so you build your best thing from first principles, and then you layer on top of it the capability that you need. The complexity happens is when that third party you're interacting with doesn't quite behave the way that they say they behave, or you're going to introduce new things to the system, and then you do the classic thing. Well, I'll just add a column, and I didn't get that fee, so we're going to add a column for a fee, and then you end up with growing sort of an unintended system. Whereas at the beginning you had something designed from first principles and a way to establish the use case you're dealing with. Over time, as you grow, entropy does weird things with us, where it starts to grow the system in a way that you didn't intend, or that you didn't have time to address. As another big one for organizations. So we kind of classify that sort of these organizational problems into kind of three ways when we're thinking about this particular problem. The first is that prototype friction. We started with Stripe and now we want to offer the line of credit. Now you have to have an accounting system, so we built one in house. Uh, the next level is, uh, hey, our company's grown. This was successful. We're going to offer a ton of different financial services, and we have autonomous teams. And so now all these autonomous teams are repeating that same history in a smaller context, right? So you build up this world of accounting where Team A has the legacy system. Well, that was a bad accounting system. We're going to learn our lessons on Team B, and Team C's over here using QLDB or something, right? So you have chaos reigns, and then the last thing is an expertise bottleneck. Sometimes uh, companies demand way too much out of their software engineering staff, and by sometimes I mean a lot of times.
Yeah.
You got to know CSS, JavaScript. You got to know React. you should know how to set up the backend for all the APIs. So you need to know a backend programming language, a database. You need to know everything about our domain, and then we want you to be an accountant on top of that. These unicorn engineers are like they're not just 10x engineers; they're like a billion x engineers. Like it's literally impossible for an organization to staff themselves that way. And then if you do get a person like that, the last thing you want them working on is like at the lowest level of your system with the least amount of leverage, right? That table stake thing
Yeah.
where they're going to be mired in like figuring out why the transactions at Stripe don't match the transactions in our database. That's going to be a waste of talent if you can find that talent. And so that's kind of what we see with this particular domain. I'm sure it's like similar in others, but that sort of chaos reigns, prototype friction, and an expertise bottleneck is where we see a lot of problems.
Yep, and that expertise one I think is so crazy or just hard in when you're talking about money and accounting. Like first of all, there's hundreds of years of experience in this accounting field of how double entry works and very solid stuff. And if you try to like you know think about it from first principles without understanding accounting, you're gonna like implement it in a non-standard way and screw something up, in a serious way. And then it's somebody's money you're talking about, which is just like one of the worst areas that you don't want to be messing up. So I totally get that. In terms of like, so you're talking about prototype friction. Is it hard in like people wanting to add new columns or figure out band-aids on top of that? Is it hard in terms of like how much flexibility you want to offer to people versus like constraining it to like, hey, here are the core concepts and maybe it being an education thing, or is that a difficulty you've had in sort of building Twisp?
I I think the building a system, a systematic way of adding new transactions or new funds flows is sort of the key problem to unlock. Even Stripe has this issue in their API where they'll have balanced transactions. It's just their accounting model, but then they'll have a fee number somewhere else, right? And so uh, those sort of artifacts are a result of like rapid iteration or finding product market fit. And for us, we had to take a step back, observe the landscape, and try to figure out a way to avoid those problems. And the way we address it is with our abstraction called transcodes, and it's essentially a way to model these use cases where a fee is just another journal entry that goes against a fee account. And so we had the luxury of seeing about a lot of banking systems, how they build these things, thinking about the problem, trying to hide those details of accounting as well, because a lot of times, uh, when you're in an organization, uh, hey, I'm really good at making the pixels look good and getting information to the back end. I don't want to think about what fee accounts are involved or what settlement accounts are involved. And even the backend engineers might not have that interest either. Uh, so there's challenges in like how do you do encapsulation and how do you encapsulate the concerns for accounting. Um, I'm sure the audience is familiar with Conway's law that organizations produce software that matches the communication pattern of the company. Uh, More often than not, when engaging companies that are building financial services, the communication pattern between the engineering team and the CFO office is not super clear.
Yeah.
It's, and it's very difficult to show up in the software. And so when you're building these accounting systems, like a clear sign of success is that a controller and an engineer can sit down and look at the same system and understand the same thing. And so that's where we are sort of measuring our success is, can I talk to the CFO office? Can I talk to a product or engineering team? And can they look at this system and say clearly that the thing that we want to happen in the product and in the financial system are the same things and represented in the software?
Gotcha. And that's where trend codes come in.
That's where transcodes
So,
come in.
all right.
So
So I read your
essentially,
post on
yeah,
transcode. Yeah, transcodes. Tell us what a transcode is.
yeah. So a transcode is a way you could think of it as a function or a macro that takes in parameters like here's the account I care about, here's the amount that needs to happen, and this is the kind of thing that's occurring, and I'm feeding it to some function that knows how to generate journal entries. Essentially, it knows that we take a fee split, so there should be a calculation and a certain set of funds going into a fee account. There's a third party or a counterparty that we need to book the offsetting entry to, book offsetting entry to the customer account. Maybe inside that transcode, it also has the ability to increment a reward system. Like they this is the 100th purchase, so they get a $2 bonus. So write that transaction as part of it. So there's a transcode's a way to encapsulate the accounting details and hide that from an application developer, so they can focus on a narrow set of parameters and not have to worry about how the accounting is exactly is done in every single use case.
Gotcha. So,
Um,
so
yeah,
thinking like of Seamless or DoorDash, that would be like someone places an order, pays for it, and I just submit sort of like maybe the card and amount information to a transcode and it's or a transcode, and it's going to deduct from my or place a credit against my card, give some money to the restaurant, give some money to Seamless, give some to an issuing fee or the card issuer, things like that. Is that
it,
am I understanding that correctly?
ex- exactly. And then the name of the game is to identify every time that we have a transaction like this. So, uh, and finding all of their different variants. So, continuing with that example, if we're paying DoorDash to go do our deliveries for us, uh, how do we book transactions to do the payout side for vendors who are providing services for us? Um, and so the name of the game is for your company is every time you encounter a new funds flow, we create a transcode that encapsulates that type of transaction, and then we have an entire corpus of transcodes that uh, that we can go and look and see. Like when I book this kind of thing in the code, it said online order. I use the online order code. We know exactly what entries are created from a macro perspective, and then we can go look at the implementation and ensure that that's what occurred. Um, so the whole goal with transcodes is lower the possibility of mistakes in accounting, and when there are mistakes in accounting, we have a place that's well known to fix them and to version those transcodes or create new ones and apply corrective transactions. Even that might be a transcode in your system. We messed up. We're going to apply a correction,
Right.
uh, uh, and and so building that whole corpus of how does our company interact with finances in our product is the name of the game there.
Are transcodes composable? Like, would I make a transcode for charging to a credit card, which 2.9% or whatever goes to the issuer, whatever that is, and then I would use that transcode within like any other transcodes that happen to use the card, or am I thinking about that incorrectly?
I like where you're going with that. In our current state, no, but the mental model that we're using is like transcode should be a pure function, and so they should be composable. So our current iteration, that is not the case. That's something that our product team is thinking a lot about. One thing with adding composition is you add complexity,
Yeah.
and so you got to weigh the benefits and risks to that. But in principle, it's possible to do, and that's something that Jared and the team think about all the time in terms of what developer experience do we want to give engineers the ability to do as well. The way we address that right now is you just create more chunk codes, and yeah,
Yeah. So you mentioned sort of the CFO, the comptroller, someone being able to sit down with a backend engineer and hash this out, or at least understand, both of them understand what's going on. what's the interface look like for a transcode, and like how will they? I imagine it's not a big blob of Python or something like that. So how do they sort of both understand what's happening in a clear way? What's that interface look like?
Yeah, so our product is an API product. So right now that is usually that's, hey, let's open up a Lucid, let's get on a whiteboard, let's draw out the chart of accounts, and the engineer constructs these something that's representative of what's in the chart of accounts and what's on that whiteboard. And it's a GraphQL interface, so a number of mutations they could create and show the controller, hey, this is what's on the board. Uh, in our next iteration of the product, we hope to have a graphical version of this, because there really isn't a domain specific tool for designing funds flows. It's usually on the whiteboard, and it's usually like not just the controller and the engineer. It might be a partner bank and their program manager on the phone explaining to you the nuances of their system, and you have to just stratify like what parts are important to you and what aren't. And so our next iteration of the product will have a user experience that's not just for developers, but also for accounting type folks to help visualize and help construct tran codes over time. And that's that's when we think we're going to really hit our stride with bridging that communication gap. Uh, right now, we have a set of primitives and APIs that allow the engineer to get a little closer to that. And it's an iterative process, like all product creation.
Yeah, yeah, cool. When I think of, I guess, like engineering around financial stuff, I think it's a very much a combination of OLTP and OLAP, right? Where you have all
Yeah,
these transactions coming in all the time, individual records, and again, you can't ever delete those, right? You make corrections by adding on new ones, but you can't delete them. But you also have these analytical needs where you want to be showing current account balances or even just like number of transactions over time. How do you? Is that something you're providing both sides of that to Twisp users, or what's that look like?
yeah. So we're really focused on that OLTP side, the hot interfaces. So, uh, like if you open your banking app, in principle, you should be able to hit a Twisp endpoint to get the balance. Um, when we think about products like banking applications, for example, we like to make the distinction between the accounting and the activity feed. And they have similar but slightly orthogonal concerns. With accounting, you're really focused in on correctness. What is the lineage of numbers that gives me the current balance that I have? With activity, you are focused on creating clarity for customers. Like when they look at the activity feed, the first thing they do is add the numbers up and make sure the balance matches. So activity does derive from accounting, but activity has other concerns that are not directly related to accounting. So, for example, uh, let's say we made a mistake uh, and uh, and the number in the accounting system was off. We might make a corrective transaction that's a void of of the original transaction and append a new entry that's representative uh, of the corrected transaction. Well, what we might do is attach metadata to the corrective transaction that says, hey, this is voiding this other transaction, and so you should hide myself and the other transaction, and then the new transaction shows up in the feed. And so, like using metadata to drive the activity feed might be one area where the activity feed is different. A customer service rep wants to be able to see, hey, there was an error and then there was a correction. The customer might not want to see that. The customer just might want to see the right number all the time. Uh, Another case where there's a distinction is transaction enrichment, and that's like, uh, can I attach geolocation to a transaction? Can I put pictures of my food,
Yeah,
what the restaurant or the receipt? because I need to remind myself to go get it expensed. So they have slightly different functions. Uh, Now, getting to like the OLAP of the situation as well. Uh, Finance teams have reporting they need to export to corporate accounting systems. You have you want to do an analysis across your whole set of accounts. That might be an accounting need. The way we address that in Twisp is we export all of our data to Parquet files that allows it to be consumed into any big data system. So I think the flavor of the day right now is Snowflake. Snowflake can read Parquet, no problem, and that's the way we address the OLAP side is make the data available in a well-known schema.
Yeah. On that same note, let's talk a little bit about just what it looks like technically for you to interact with a new customer. Are you are you completely a SaaS and they interact with it via API? Are you deploying into their account or on-prem somewhere? What does the deployment model for Twisp look like?
Yeah, so that's an awesome question, and it goes to sort of the way we view the cloud. Twisp itself is entirely a serverless application. It's deployed via CloudFormation. And so when we think about what we call our cloud offering, is basically an application that's a multi-tenant system, and you interact with it purely via API. You have the ability to interact with it with your control plane as well. So we have CloudFormation providers to spin up resources in our system if you choose to go that way, or you could just use GraphQL and create the resources you need to spin up your particular accounting system.
Wait. So
Now,
hold on, just to make sure I understand that. So you have like CloudFormation custom resources that if I'm making some, if I have my DoorDash application and I'm spinning up all this stuff, I can also spin up a Twisp resource as part of CloudFormation.
yeah, exactly.
I love that.
CloudFormation has their CloudFormation providers. They're kind of like AWS's answer to Terraform providers, as my guess.
Yeah.
And so we implemented that. What our original vision was, we want this thing to look as good as an Amazon Teams, like we were part of Amazon, and so that's the route we went. Um, and that's part of the learning process as well, because interestingly enough, the way we write software is different than than other teams write software, as it turns out. And some teams split the infrastructure as code duty to a whole other set of people, and actually that's a friction for some teams. And so that was one of the lessons we learned was like, yeah, the cloud formation is cool for people that think like us, but when people don't think like us, they also need to have tools that don't get in their way. So that was a pretty interesting learning for us. So there's the cloud model. Um, we have another model called dedicated, and this is for like banks that are very banks or financial institutions or insurance companies that are very concerned about uh, the criticality of their data. They don't want their data having any neighbors. They want to live in the country by themselves. And so we offer a dedicated model as well, where we'll spin up an AWS account and deploy Twisp into it. And then it looks and operates and feels just like the cloud account, except for it's isolated from everyone else at our layer, and our customers can interact with that account.
Yeah.
So a couple of different deployment models, but at the end of the day, they both look like a typical SaaS cloud infrastructure type of tool that they're using.
Yep. I love that that note you were saying about just how there are some teams that sort of ship like y'all, but some that don't. And I've seen a PowerPoint that y'all have about the Twisp way and how you do engineering. Can you talk a little bit about? You mentioned fully serverless and CloudFormation. Like, how are you sort of? What are the core tenets of Twisp and how you build Twisp?
Yeah, so I think the proto ideas for how we think about the cloud were formed when we got acquired by BBVA. Jared, my co-founder, and myself went up uh, into that company, and we were on a team to launch a banking as a service application. And that team was like three people: me and Jared, and our manager, and then we were assigned a team in Spain to help us with engineering effort. And the first thing we we knew is like, in order to be successful, we have to have infrastructure out of the way. That can't be a blocker for us. And so at that time, it was around 2017, the ideas of serverless, like systems like Lambda, Dynamo, SQS, et cetera, S3, were very popular. And there's this idea that, well, they're constrained, and we took a sort of uh, a different take, is like, maybe we should lean into those constraints and use that as a guide for building good software. And so that was like the original idea. And we built this banking as a service API in a traditional serverless stack now, with API gateways and Lambdas, et cetera. As Jared and I started thinking about this accounting system, we had a lot of parallel ideas were coming in the sphere. You're a promoter of some, people like Zach Cantor, um, uh, Brian LaRue, like a lot of people on the internet are talking about how to build serverless systems. And our take on that was, what if instead of thinking of managed services as managed services, what if we thought of the cloud as an operating system? And how would we build things if we were treating the cloud as an operating system? So what if Lambda was just a CPU core? And what if Dynamo was like a glorified B tree? And how could you build a system or systems on top of that abstraction? And so that's where, from a philosophical point of view, that we started that, and that's how we started building things the Twisp way. So, for example, on our team, an engineer is not only building like the API and backend system, but they're also building all the cloud infrastructure to support it. Uh, and when I say cloud infrastructure, it's more like AWS offers these abstractions that make it easier to deploy the software. So as part of the application, you're also building to those APIs to get your application up and running. And so the essence is to strive for zero toil. That's an aspiration. Doesn't always work out that way,
Yeah.
but that's the direction we're going. So you won't see a ton of containers or Kubernetes clusters in our stuff. We don't have a big SRE function in terms of like provisioning a platform for the engineers to build on. We view AWS itself as that platform.
Yeah. Awesome. I love that. And I love just seeing teams where, the application developers are not just writing the backend code, but they're actually provisioning that infrastructure. I think you have so much more power and just speed and agility when you're not waiting around for someone else. When I think the tooling and sort of the abstractions have gotten there that you can do this a lot quicker. There's a little bit of a learning curve, and then you can really do some amazing things. Any like particular services or patterns or things that you tried using and then were just like, oh man, this ended up being a nightmare, and sort of ripping it out, or any horror stories there, or even good stories if you have some too?
Yeah, so I mean, I'm always trying new stuff,
Yeah.
and we had a period of time where we were doing consulting, and this shop was building a loan origination system on top of Salesforce. And so, like, whenever a software engineer encounters Salesforce, that's like that's like one of those software engineering. It's like a forward horror story, right?
Yeah.
uh, and so AppFlow came out like literally like right when we got this gig, and the thing was, how do we take uh, how do we take lead data that's coming into our API and ship it over to Salesforce? It seems like a beautiful case for AppFlow. We must have been like user number 5 of AppFlow, because it was that kind of experience. If
Including
you
the
look at that,
internal users. Yeah.
right.
Yeah.
So it mostly worked, and there was a lot of problems. Um, and we do our, but when we're dealing with the cloud, we are heavy users of AWS support. They're great. Um, and a lot of those bugs got fixed. Uh, we ended up actually calling the Salesforce APIs directly ourselves afterwards, just because I think we were a little early for that use case. Uh, but like that's the risk as an early adopter of managed services is sometimes they're not fully baked. Um, so that was a little bit scary. I have a lot of stories about just non-serverless dealing with
Yeah.
the legacy system. When your settlement account's down $1 million, it's scary at first, but when you do it a few times, it becomes not so scary.
Yep.
So
Yep. Oh man, that's fun. Yeah, that story on AppFlow. Yeah, I guess in my sense, man, AWS is so good at just like those core fundamental building blocks like compute, Lambda, Dynamo. Like you're saying, a B tree, Kinesis streams, S3. Like those things are good, but like the
yeah,
sassier it gets, the more higher level it gets. I think it's just a little trickier for them. It's more hit and miss, I would say, than compared to like those fundamental building blocks. And then you build the domain specific stuff on top of it. So yeah, that's what I was sort of thinking of when I heard that.
yeah, yeah.
One thing you mentioned earlier, this was a while back when you're talking about all the different teams maybe building their own stuff, and you mentioned maybe one chose QLDB. So QLDB, Quantum Ledger database from AWS. How does that compare with Twisp and what you all are doing there?
That's an awesome question because I think QLDB is like one of those. Well, the word ledger is so overloaded that
Yeah,
we need to figure out a way to describe what a ledger is. QLDB is a great append-only data structure that gives you cryptographic proofs of tamper evidence. So for us, we think of QLDB as a Merkle tree as a service and less as a database. If you look at QLDB from a database lens, it becomes less attractive. It can only handle 1,500 concurrent transactions. In a card settlement use case, you might have hundreds of thousands of card transactions landing on you all at once. And those batch use cases, QLDB might struggle. Another thing would be the 40 table limit of all time. Uh, it's really hard to write legacy software on a platform that only gives you 40 tables. so
yeah,
so so it has some constraints that are just a little bit too tight to use in an accounting use case. Um, for that's hooked up to the financial networks. Now, some of our customers and some of the folks that we've talked to have built those systems on top of QLDB, and they've worked around those constraints with like sharding and smart load balancing and things of that nature, strategies like that. Um, but for us, we look at QLDB as, hey, it's a Merkle tree as a service. We can use it to generate tamper evident logs, and that's how we use it. Is generate hashes and show that our system hasn't diverged from what QLDB says that our system is. People have people like those types of features. Uh, I don't know how often someone runs the proof endpoints on QLDB
yeah,
for an auditor, but it's a nice to have in the back pocket.
yeah. Yeah, I've seen, there are a lot of people that say, hey, it's QLDB it's got some really great interesting use cases, and it's always tricky to like actually tease those out and find what those are. So that's helpful for me. Yeah, and this has just been a great conversation overall. I love people that just like really know a domain really well, and now you've been working in this area for a long time, and I'm sure have seen a lot of things, and now building something to make that easier for a lot of folks. I think it's great. So thanks for coming on and for discussing this. Anything you want to share about, I guess, like where Twist is going, or anything you're particularly excited about going forward?
Yeah, so our ultimate goal is to manage all the financial data for all companies. And so for us, that's going to be creating world-class developer experience where developers are, it's just a nice fit in the toolbox for dealing with financial problems in products, and then also bridging that gap between the developer and the engineering product teams and the CFO office. The thing we want to see go away is companies having to move money into from operational accounts into settlement accounts to make up for losses that they can't explain. And the best way to do that is to have an accounting system that knows as much about the world as possible. And so, bridging that communication gap between those two functions of businesses are what really excites me. Having been in the trenches myself a few times in those types of challenges, it gets me excited to actually solve that and have the time and headspace to go build tools that make that happen.
Awesome. That's great to hear. Well, everyone listening, go check out Twisp, TWISP, if you're in the market for something like that. Mike Parsons, CTO and co-founder of Twisp, thanks for coming on Software Engineering Daily.
Alex, thank you so much.